Hello, everyone. It's 8 a.m. Pacific time here. If you've just joined in for our insights from oil and gas companies successfully implementing UAS programs, it's 8 o'clock and we're going to give a few more minutes for some people to join in, but we have our panelists and speakers already joined in, and we want to thank you. Alrighty. It's been 5 minutes after the start of the webinar. We can begin. So as a reminder, this webinar is real world applications and lessons learned from insights from oil and gas companies successfully implementing UAS programs. Before I get started and introduce some of the speakers, I'd like to start a poll. What sector are you representing today? Give you guys a few minutes to answer the poll. All right, I'll be closing the poll shortly. Looks like 80% of the attendants answered. Okay, I'd love to share the results with everyone today. Looks like other industries came in leading with 62%, and then trailing behind oil and gas 31%, and personal 25%, and utilities 16%. Today we are focusing on oil and gas solutions, but I would like to welcome everyone else from other industries, utilities, and any personal sectors also. Thank you everyone for joining. Close the poll. So as a reminder, said it in the beginning, we'll say it again today, we're doing real-world applications and lessons learned, insights from the oil and gas companies successfully implementing UAS programs. I'd like to give a little introduction to some of our speakers and myself. Right here, I'll just be kind of giving over their title positions and their names. In the next few slides, I'll let them speak more about their position and their impact on the oil and gas UAS industry. So yeah, myself, Michael Lee, I'm a solutions engineer at DJI, and I'll be leading this panel today. Also, we have John McLean, a security specialist and chief drone pilot at Pemex Deer Park, and Clint Johnson, who is project manager in pipeline inspections in the oil and gas industry. So kind of diving into the origin stories from our speakers. Well, let me start with today's webinar outline actually. So today's webinar outline will consist of origin stories from our speakers. So that'll give the opportunity for our speakers to talk about a little bit about their experience in the oil and gas and how they kind of got started. And then they'll be able to speak about their solutions and what they're doing with drones right now in oil and gas. And then they'll be able to discuss some of those results that have been produced from their UAS program. And then at the end, we'll have a survey available for you guys to answer, get some feedback. And then at the end, we'll also take some Q&A. I believe some of you have already answered already asked some questions, so we've included that in the slideshow. And then we'll also be taking live questions in the chat also too. So that is today's webinar outline. Diving right into it, the question we want to ask our speakers today is how did we start to use drones in oil and gas? I'll start with Clint Johnson. I'll pass it over to you, Clint.
Yeah, so I started as a police officer. I helped a police department that I worked for start their drone program, and talking to more people and trying to get them to understand that drones are so much more than just a flying camera. What they can do, what they can accomplish, how they can help increase safety and productivity. The more I talked to people, the more they wanted a drone program in their sector. And talking to somebody who was in the oil and gas industry and having a tough time maintaining safety and efficiency, I started talking to him about options and how he can increase safety, productivity, and save money all at the same time, which is exactly speaking executives' language, of course. And that's how I transitioned to starting programs for several different oil and gas companies in Texas and Louisiana.
Thank you for that, Clint. Also pass it on to our next speaker, John McLean.
So we started here, Pemex, previously known as Shell. Everything that Shell had previously has moved over to the Pemex. We started in summer of 16 doing the financial studies and proof of concept of using drones here in the refinery. We had a drone company come out, third party, do a demo. The next week, a young engineer was walking by or under a 265 foot stack and looked way up there and thought he saw a handrail that was fixing to fall. So we called that company back to do a demo or to actually do the inspection on top of that stack. They were able to show the engineer live pictures, 4K video of the handrail up there, and everything checked out to be okay. Shortly after, we received a significant bill for 15 minutes of work, and my manager decided that we could do that ourselves. And so we started a first of a kind where at that time Shell employees were flying Shell drones, and it just grew from there. Where we do inspections, we're a big part of the emergency response. We do external items with the city of Deer Park, and we're also a part of the local mutual aid system here in the Houston area.
Absolutely, very active, John. I also have this slide for you.
So when we started, we came up with a three-pronged mission statement. Course number one should always be included, with your program to outline to your leadership is the safety piece. So we use the drones anytime where we can save a person or keep a person on the ground instead of putting them up either rope access, up in scaffold or whatnot. Our first option is always use the drone. The second piece that I've already mentioned is we're a huge part of the not only the local but the mutual aid system of doing situational awareness and tactical vision during any sort of emergency response, and that's from the ambulance rolling on site, all the way to a major fire. Anytime the alarm is sounded, we are rolling with the emergency response team. And then last is to reduce the cost of rentals as far as scaffold, man lifts, and cranes. The dashboard there, that's kind of outdated. That's actually from a few years ago, but as you can see, we've been in the air a few times. Let's see, next slide for me too.
So yeah, I guess a big question I have hearing the origin stories of you guys beginning your UAS programs in oil and gas. I know it's not always easy. There could be sometimes blockers in the way, potentially chain of command. I guess one big question when starting your program, how did you get the buy-in from leadership when starting your program? I know that can be difficult. A lot of people here today don't have a UAS program or maybe have a small one and want to build on that and get better and better. What's kind of like the advice or you recommend when starting your program or getting that buy-in from leadership?
So of course, when we started in 16, drones were still viewed as toys. And when you tried to, hey, we have this piece of equipment, this tool, they'd kind of smirk at it and, what can it really do? So shortly after we started the program, that very summer, we had the event Hurricane Harvey, where we got the upfront attention of the entire site leadership, and they were able to see that it was a tool, a very valuable tool, so valuable. We'll have some slides here about Harvey later, but it's the quickest that this site here has ever recovered from a hurricane, getting a damage assessment done, checking off the boxes for the process safety startup review, and just getting everything back online. The second big win for us was the big ITC fire event, which I'll have some slides on here shortly. But there we basically had the whole emergency response, mutual aid systems attention, where the drones were giving them views of an incident that they've never had before. And they were being able to use the drone all the way from individual team tactical assaults, all the way to, is my equipment where it's supposed to be. So it's just being able to, one, grab your site's leadership attention and able to show them the value of the tool, the safety of using the tool, and then of course the last piece there, on our goals, number 3 is the numbers, the dollars amount, which I'll have some slides to kind of cover that too.
Yeah, that's very intriguing. Yeah, at the end of the day, it's a business and saving the business money. So I think that's a good way into the heart of the leadership, get them convinced. Clint, I know you said you started as a police officer and kind of transitioned over. How exactly did you kind of get the buy-in from leadership when joining your new industry and new program?
Yeah. Every time I've talked to leadership on any oil and gas company that we've worked with, the same thing is kind of their focus, is they want to know if it's going to save money, if it's going to be more efficient, and if we can be safe doing it. And rarely do they get all three when anybody brings them a presentation. Rarely, or most of the time, they have to sacrifice in one area. And with drones, that's not the case. The big thing is what John mentioned about including multiple different groups of leadership to let them see what all it can be used for. That's one of the biggest hurdles, is they don't understand. They think that we could just look for methane leaks, or we can just get pictures of the sites. And to get several groups of leadership together and explain to them, no, I can help you increase safety, and I can help you increase geolocation on drilling sites, and I can help you with presentations with 3D models. And we start to show several different areas that I can help each one of you. It makes it a no-brainer. And when we show the increase of safety and how much money it saves, and how a week of work, a lot of times a day of work, can pay for the program and then some, it quickly becomes a no-brainer.
Yeah, able to produce so many different solutions, but yeah, saving money and being safe at the same time seem to be a pretty big key. Thank you for that, gentlemen. Next on the webinar, we have oil and gas solutions. Big question going into oil and gas solutions is, why do we need drones in oil and gas? So I think I'll pass it over to Clint to show some of his solutions as a pipeline manager in the UAS industry.
Yeah, so as you can see at the bottom, that's just from 2005 to 2020, how much leaks have cost in the US alone. And what you run into when the traditional methods of inspection is, there's a few different ways they try to go about it. And that's driving the pipeline, or walking the pipeline, or paying a lot of money to have planes fly over. And the thing that you run into is, you can't do it efficiently enough to cover your pipeline as often as you need to actually prevent these leaks. A lot of times you're coming in after the fact and you're playing cleanup. With drones, you can cover so much ground and you can stay on top of it so much that when you do find the leak, it hasn't had time to cause damage. As you see on that picture on the right, the big thing though is the safety of it. they talk about class 1 div 2 safety, where you don't want to bring anything that can cause an explosion onto the pipeline or into the facilities. Well, it's unrealistic to feel like you have everything covered. Your cell phone getting a text message can cause an explosion, but with the drone, you can fly high enough that you are out of any kind of danger area and you keep people safe. There's been several incidents over the past year in Texas and Louisiana where people on a side-by-side or a four-wheeler have ignited a pipeline leak. And with the drone, not only are you flying so high it won't ignite, but if it does ignite, now we're just hurting a drone versus hurting a person. And that appeals to leadership quickly. So those are examples of how it was done before. Somebody would walk with one of those or hold it out on the side of the side-by-side, or they would hook a rig up to a four-wheeler or a side-by-side just like that. And that will find the leak, but when it finds it, you're in the middle of it, and it's not really where you want to be. You also run into flooded areas that make it impossible to pass. There's a lot of times that they just can't inspect the pipeline because it's flooded or there's too many issues. It's also dangerous. In Texas especially, we have a lot of hunters, and when you're walking or riding these right-of-ways, a lot of times they have deer stands on these right-of-ways, whether they're supposed to or not, they do. And it becomes dangerous. You can run into hogs or whatever out here in Texas and Louisiana, whereas the drone can do it safely and you can fly next to your truck. You also have pipelines that go into backyards, into different plants. They cover certain areas. It's hard to gain access sometimes, or it's just tedious to gain access, where the drone can fly over the top of it. And a lot of times I don't even have to access gates. I just stop at the gate. Then again, there's another example of a pipeline explosion. It is very dangerous and it happens more often than you think, and not with drones. So here's an example of a flight with the U-10 that I did. You can see how much ground it covers in seconds, whereas before we would have to walk or drive it. That pipeline extends going west over fences into backyards, and we're able to cover so much area. That took, I'd say, a minute of flight, and we've got a leak on that wellhead right there. And we were able to zoom in after with a live view and find what we need to find and get all the details we need to. But more important, I didn't have to open all of those gates to go to all those well sites. Now I just narrowed it down to one location I need to go and further inspect. The amount of time it saves is incredible.
Yeah, that leads me to our DJI enterprise flagship drone, the Matrice 300 RTK. I'll kind of give a quick overview of this powerful device. The aircraft is capable of long distance flights with strong battery and transmission range, obstacle avoidance and sensing, also IP rating, so you have the ability to fly in the rain and other rough conditions. Throughout this webinar, I think you'll see a lot of photos and solutions, and I could tell you the M300 RTK is the reason a lot of these solutions are possible. This is the go-to drone for many UAS programs across the world today. On the next few slides, I will be able to present just some of the payloads out of the many that are available with the M300. The Zenmuse H20T is a popular choice. The H stands for hybrid, and that's why the payload is so popular, is because of its quad sensor solution it provides. The 20 megapixel zoom camera, 12 megapixel wide camera, 1200 meter laser rangefinder and thermal camera. With these sensors, you're going to get functions such as click to aim, smart track, high resolution grid, and night scene. So this is just one of the many payloads available with the M300. And then another popular payload that Clint was also talking about for the methane detection is the AILF U10. It's a high performance laser methane detector. It detects CH4, which is methane, and has a quick response time of 25 milliseconds and a range of 0 to 100 meters. So really popular methane payload that's available for the M300. For different payloads, we also have our enterprise ecosystem eco solution category on our website. You can take a look at some other gas sensors if you're interested on our website at enterprise.dji.com/ecosystem. So going into a question for you, Clint, what are some strategies and settings do you use when flight planning for leak detection? After we talked a little bit about the U10, I know you spoke about that. What would you recommend?
So a lot of oil and gas companies have KMZ files. I think all of them are required to, listing where their pipelines are specifically. On a lot of times it's on a Google Earth type format. So what I'll do is in the office, I will pull up these KMZ files and I will draw out my mission plan from the office, drawn along the right of way. I'll try to stay along the right of way and then see the wind direction of that day and have my return trip going with the wind to try to catch it. A lot of times what you're going to run into is pipeline is 4 feet to 20 feet underground. And so if you do get a leak, methane can pop up. It's going to take the path of least resistance coming up out of the ground. And so you don't know where it's going to pop up. So if you do one over the right of way and another with the wind, you're able to catch what you need to catch. And if you do that flight planning before you get there and just pulling up to the location and hitting play, it's incredible how much ground you can cover. Similar with running over our compressor stations and facilities, I'll do the flight planning and just going back and forth in about a 10-foot gap, and I'm able to pick up what I need to from there just with the gas cloud that'll come from it.
Awesome.
Oh, and I'm sorry, at about a height of usually 100 feet is what I do. The U-10 can do a lot more, but at 100 feet, you're able to get the detail you need to. I'll run the U-10 with an autonomous flight, but I will manually control the gimbal. And that way I can kind of sweep the right of way as I go. You want to keep it close to a 90. If you get too much to one side, then you're not accurately picking up whatever's coming out of the ground. And so doing a manual control of the gimbal, but letting the drone itself do an autonomous flight, it makes it very easy and efficient.
Yeah, it keeps it a lot more consistent also.
So with saltwater, what we've been doing is we've been dealing with multispectral sensors. I've been flying the Phantom 4 multispectral, which has worked great. And I'm anxious to try the Mavic 3 multispectral, which I'm hearing great things about as well. But what you run into with saltwater, a lot of pipelines are full well stream, which means that they are pushing oil, saltwater, and natural gas through the line. Sometimes you'll just get a saltwater line, which makes it even more difficult to detect any kind of leak. The way they're doing it now with just saltwater lines is they're just waiting for a mess, to be honest. They have no other way to check other than pressures in their systems. But if the pressure isn't altered enough to raise a red flag, then they're just waiting to be standing in a puddle and realize, oh, we had a leak. By that time, the landowner could have lost cattle, they've lost trees, they're in a bind, and it's out a lot of money, and it's oftentimes in the 7 figures. What we do with multispectral is with full well stream lines, I'll run methane detection first, and if I get a methane hit, like there's a leak, then I'll run a multispectral run after. And now if I have vegetation that's dying, so what multispectral is for those who don't know, is grass may look green and healthy with the naked eye, but when something is killing them, the vegetation spends off stress signals, and that's near infrared data. And so if you run multispectral over it and you're getting stress signals from the vegetation, you can know something is killing it. So if I have a methane detection and then I have stress signals coming off the vegetation, now I have enough to know I have a sizable leak, and we can dig it up and handle it before it comes to the point it is killing cattle and killing trees. And we are taking a couple thousand, tens of thousands of dollars fixed now versus in the millions fixed. And so it's been a very successful way to look for those saltwater leaks. And again, on purely saltwater lines, you can't rely on methane detection. There will be some methane because you can't clear it all out, but there won't be enough a lot of times to get a detection. And so relying on the multispectral is the only current way to find it before it hits the ground or above ground. And it happens a lot. These lines have a lot of pressure on them, and some of them are old. And these oil and gas companies do a great job of maintenance and trying to maintain them, but there's only so much you can do. And so a lot of times it gets to the point where they have to be reactive. And so these leaks cost oil and gas companies millions every few years, or sometimes yearly, depending on how much pipeline they have. So showing them that you could save them millions of dollars with a $10,000, $20,000 sensor or a $100,000 drone program, it makes it a no-brainer for them. They're saving millions in one incident, and it pays for the program itself. That's an example of the Mavic 3 multispectral. But the Phantom multispectral has worked great, and this is an upgrade from that. NDVI, normalized differential vegetation index, is just another, that's just the multispectral. Sorry, go ahead, Michael.
Yeah, so people probably are wondering, I mean, do you just, use the drone? How do you process the data? Is it, just get an SD card? So I guess that leads me to a little bit of talking about DJI Terra. DJI Terra is a PC application. We have a software that is able to produce 2D ortho photos, 3D models for reconstruction, functions also as 2D multispectral reconstruction, LiDAR point cloud processing, detailed inspection missions. So this is where you're going to transfer that data from your SD card to the DJI Terra, from your Phantom 4 multispectral or Maverick 3 multispectral. To kind of understand, I think you went a little bit into it, Clint, but to kind of understand how multispectral imaging can help us in vegetation and crop management and leaks, we kind of got to understand the mechanisms behind the multispectral image itself. To kind of introduce you to it, I guess a simple way to think of it is like all objects kind of absorb and reflect solar irradiance in different ways, and of course this holds true when it comes to anything alive, such as plants or vegetation. Simply put, the ratio of the amount of light leaving a target to the amount of light striking the target is called the reflectance. So every plant has a specific amount of light reflectance, which produces this unique spectral signature, and the different types of vegetation differ in the reflective values, which kind of gives us different spectral signatures. So to kind of give you an example of how DJI Terra works is you would open up your Terra, you transfer your data over, you have your multispectral, so that's where you would click, and as you can see, all different output indexes. So that's just kind of what the drone is gathering. So you have NDVI, which is a normalized difference vegetation index. You have GNDVI, which is your green normalized difference vegetation index. So these are all different types of vegetation induces. So that's where your data is kind of come into, and then from here you would process your data and kind of plug in your inputs. In the next slide, I'll show. So you have on your left right here a processed RGBI mission, and then you have a NDVI output, which is, like I said, the normalized difference vegetation index. So right here, actually, it shows the vegetation and measures it by showing the different lights. So with actually red is what the vegetation absorbs, and green is actually not healthy. So I know it can look kind of confusing at first, but this is kind of what DJI Terra is able to produce with that Maverick 3 multispectral. So I'll kind of go into a little bit about the Maverick 3 multispectral. It has 4 different readings where it's able to get with 5 megapixels. That comes with the RGB camera, and also has omnidirectional obstacle avoidance with that 15-kilometer transmission distance. So this is kind of the DJI Enterprise newest multispectral device in the industry right now. So thank you for that, Clint. I'll go over into, people are excited to hear about John and his adventures at Pemex, so I'll go into that for him.
So just to highlight again a little bit about the program. So we've been through the Argus audit and received a gold rating for our SOPs. I myself, as the chief pilot, I'm a top level 2. DJI's enterprise partnership has been a big part of our program almost from the beginning. We'll review Harvey here in a minute. Also ITC, as I already mentioned, we do all kinds of visual inspections to include OGI for leaks, a big part of the emergency response, and we also have the capability to do confined space inspections. Next slide. So start off with the SEMA response to ITC. So top left slide was day one, single tank on fire. Moving to the bottom left, which was morning of day three, they had 3 tanks collapse almost back to back to back, and which resulted into basically the entire inside of the firewall was a big ball of flame. In between there, like I mentioned, the drone was going back and forth to being assigned to individual attack teams for individual tanks, trying to find the holes that the fire had created and where they could start, getting the cooling water and the foam into the tanks, all the way to top right to when the fire was out. Of course, right off the bat, they lost electricity to the pump, so they had to gravity feed all the products out of these different tanks. So after the fire was out, we were able to use the thermal and show what was the level of product still left in the tanks that were still standing. Moving down to the bottom right to keep in a good foam blanket on top of the now mixture of chemicals and products that were now, I think it ended up being 2 to 3 feet deep over the entire tank, inside the entire tank wall. So anytime that foam blanket broke down, most of those products, including naphtha, as soon as it hit the oxygen, it would reignite where the foam had to be reapplied. So like I said, on this event, had the capability of doing accountability of the equipment. There was some techniques at the end where I was able to show command. My famous quote is, hey, I'm not a firefighter, but looking at this foam attack, I don't think it's very efficient. And he looked at it and, of course, immediately got on the radio and was able to dial in the 3 different foam streams and to finally put one of those final tanks out. So very useful tool, not only for inspections, but big part of emergency response. Next slide. So environments where you would rather put the drone in than trying to put a person in. Steam leaks. So one of the very first steam leak was right after we were recovering from Harvey. We had an expansion joint develop a steam leak close in view there, bottom left, and kind of out overall view, top left. But before DJI came out with the capability of recreating an image over and over and over by just hitting a button. We basically took note of the GPS position, the angle of the camera, and that bottom left image we ended up taking every 30 minutes. And by the volume of the leak and the size of the leak, the engineers were able to calculate the size of the hole in the expansion joint, and also were able to make the calculations if it wasn't blocked within 10 hours, then basically that entire pipe rack there that was pictured on top left was basically going to go into pieces from the pressure of the release of the final separation of that expansion joint. Moving to the right side, it was a 220-pound steam leak after the March. We've termed here in Texas the Great March Freeze. So basically that valve, that's the zoomed in image there, was basically split in half. When I was looking at these images live, I was basically asking myself, how is this valve still halfway almost intact? But the big win on this incident was we were able to use the drone to get the model number, the size, the specs off that valve with the use of the H20 and its zoom capabilities. And this seam system was not taken out of service until the valve was on site and was ready to be replaced. So didn't have to take down that one of 3 different steam systems here on the site. Next slide. So one of the big inspections that we do weekly is the site has started off with 52 external floating roof tanks. It's now down to, I want to say 45, just with upgrades, and now the ones that we previously inspected now have geodomes on them, so we don't expect those with the drone. But this inspection first started out as after a 2-inch rain event in a 24-hour period, we would go and inspect the roofs of all the external floating roofs and make sure the water was draining, but also making sure that not only water, but there was no product on top of the tanks, roofs, all the pontoon hatches or hatch covers, as pictured there on the left side, were still in place. On the right side, an example of just showing that the 2 seals on the roof are still in good condition, where there's not product on the side of the wall. But also you can see the picture there, image of the pontoons and different aspects of the tank. That's now done weekly, and it's shared with the logistics and the maintenance tank maintenance groups weekly. And the items I don't obviously see with my security and law enforcement background, they're able to pick out, and that's how they plan their maintenance for the rest of the week. Next slide. Another big win for the program is the drones now do the annual flare inspections. Just some different examples of what the drone can pick up with the zoom capabilities. Bottom left, it's basically the steam ring is separated, a pretty large, significant steam leak there. Top right, you can see one of the thermal couplers is damaged and needs to be replaced. Down to the bottom right, where we use the thermal to confirm that the pilot lights are lit and seem to be burning efficiently. But we've been doing the annual flare inspections for about 6 years now. But not only do we do them annually, but anytime after a storm event, a freeze, anytime that the flares are used heavily, because the site had to shut down, one way or another, either controlled or the term it came down hard, we do a flare inspection to make sure they're still intact and working efficiently. Next
John,
slide.
if I can real quick, the flare inspection is huge for oil and gas executives to hear that you can do. The way that they inspect flares before drones, a flare is essentially your safety. If you need to get released gas, it has to go a different way. If a compressor shuts down or something happens where you need to vent off gas, that's what the flare is for. They can't run their operations without the flare. And so the way they inspected it before is they would have to shut the flare down and shut the gas down. And that shuts the oil production down, and that shuts the gas down for that day. And it is extremely expensive. Costs hundreds of thousands of dollars, sometimes in the millions, how much oil and gas they lose for that time period. When you show them that you can inspect now without having to shut it down due to the zoom capabilities of the H20T, that is tremendous for them. It helps a lot.
Yeah, Quinn, I've even visited multiple oil and gas companies, and previously to drone inspections, they would do such a thing called a turnaround, right? Where they basically turn it off and they hire a ton of third-party contractors or just anyone they can get to do inspections and routine as fast as possible, because while that flare is turned off, essentially you're losing money. You're not producing what you're supposed to do in oil and gas. So with drones, it seems like it's very easy that it's very appealing that you don't need to do a turnaround, you don't need to turn off. You can still be producing what is making you profit and money, and also be able to safely inspect that flare. But yeah, thank you.
It's not only the money part, it goes into the safety part. So now flares that now belong to Shell, but of course used to belong to all of us. The Olefins flares, they couldn't shut those down. So basically they put people up there in baskets, but then also there would be standby rappelling ropes that went to the ground. So they basically had seconds warning to say, hey, the flare is being lit, and they would basically have to jump off that flare tip and rappel to the ground. So yeah, I mean, it's made night and day using the drones to inspect flares instead of having to put people on top of those flare tips. I think our tallest flare again is about 275 feet. There's two of them. The Olefins flare, nicknamed the Twins. But yes, money and safety pieces of using the drone. So our first big success was the Hurricane Harvey. We began our program with Phantom 4s, and of course, as you can see above my shoulder there, a surviving Inspire 1 that's used still today for very limited reasons, but still in the fleet. But we put our two Phantom 4s in service as the last bands of Harvey were still passing through. So we were able to get these images here, specifically of our docks that could not be accessed, through the roadways that are now flooded. And we were able to find, I think there was 3 tanks that had floated from their foundation. We had a substation that powered this entire area that was fixing to be underwater. We were able to find a couple pot tanks and frac tanks that had been floated and overturned and were leaking. And I think a vacuum truck that was about halfway up the tank that was also leaking. So several different items where the emergency response teams could start putting their plans together, so when they could access these areas, they could start mitigating those issues. Another big concern, kind of closer up on the left image there of the dock causeway. Of course, that dock causeway was designed for the ship channel to be pushing on it and not for flood water to be pushing on it. So there was the fear that we were fixing to lose that dock causeway. So multiple flights over the dock causeway just to able to see its status. We also were able to find, I think we had 3 external floating roofs that sank, and we were able to catch all 3 of those basically at the same time because we were asked to go fly 1 tank that they had suspicions on, and as we were in the air, we were able to find the other 2 at the same time. So we were able to bring back the information. At that time it was, live streaming wasn't quite thought of quite yet, but it was after this event. I brought it up to, at that time, Kitty Hawk and said, hey, live streaming would be great. And so they quickly developed that for us. And also they had another partner customer that was asking for live streaming. And that's how we started live streaming. But at that time, Hurricane Harvey, we were basically walking around like this with an SD card with 2 or 3 people following us, wanting to know, hey, is that my images? Is that my stuff? And hang on, we'll get it to you. But able to find the floating roofs that had sank, huge win for us to quickly mitigate those issues. Also, that was developed in Harvey that we carried over to ITC was the monitoring of the foam applications and monitoring those blankets until they started to break down where foam had to be reapplicated, and then to monitor the application to where just enough foam was used to cover the top of the tank, because at this time we were an island, and basically what foam we had on site was all the foam we had, and we weren't getting any more. So if we did have a fire event kickoff, we would need that foam. So it was just using enough foam to cover the top of the tank and then shut it off. So like I said, lots of money saved on the damage assessment from the air. Started, even as the storm was still passing through, all the way to, like I mentioned before, the inspection of PSSR, where we inspected 270 fin fans in a day. That night, the engineers looked at those images, gave us a list of 25 fans they wanted a closer look at. We did that within a couple hours, and they were able to check off the box on the PSSR for fin fans within a day and a half, which at that time was unheard of, without having to build scaffold putting people above each one of those 270 fin fans. We did it in a day and a half and checked the box. Next slide. So as I also mentioned in the beginning, we also use the drone program for external relations. We've done internal and external commercials for the site. We did a safety day video named Follow the Barrel of Crude, which basically took a barrel of crude from the ship all the way to the tanks, to the distilling unit, and wherever it went from there, we basically used a drone, and 95% of that video was drone video. With the community relations, like I said, we support the city of Deer Park on several things. We supported one of their EOCs with live streaming videos and tethered drones on one of their big events for their city anniversaries. And I also support 2 different STEM programs in the area with just talks like this to when they go to different competitions. I go there for support. The Galena Park ISD now has an annual event called the DJI Academy, basically where their 8th graders have to pick their career path, for going into high school. So go in there and present drones to them for that. Next slide.
Yeah, that's a good point. A good point to ask you some of this question. So I know you kind of talked about the steam leaks and the EFR tank inspections, the FLIR inspections, and even the success story with Hurricane Harvey. But a big question I think people want to know is how often, what is the frequency for these different inspections? And is there any particular flight parameters being used for these vast solutions that you have at Pemex?
So as already mentioned, it's basically annually. Is the big inspections are annual, but there is more frequent ones, weekly with the floating roofs. And then anytime we have a large storm, like a hurricane or a freeze event that we know that's coming, we'll do a pre and a post inspection of basically the entire site. We also found during Harvey that the drone videos and images, it was able to, through the insurance, recover millions of dollars that previously wouldn't have been able to be documented. And just from storm damages, of our videos, we were able to show that to the insurance company. And I want to say the final amount was 30 million we were able to recover from the drone images. So any specific flight parameters used, it depends on what type of inspection that we're using. I use the same planning techniques as Clint does. It all starts here in the office. I'll get a request, what needs to be inspected. I go through my software, I'll plan my mission, all the way down to which drone am I going to use, to which camera am I going to use, or am I going to use multiple cameras. I like to go out when I do my inspections, as I mentioned before. Doing this over the last few years, I have learned a lot about the different pieces of equipment, but there is times where I get just to throw down my security guy card, and I'll bring an engineer or an inspector with me, so they can see the video either on the controller, or I'll hook it up to a monitor where they can see a larger picture. And if they see something they want to see a little bit closer, then it's easier for them just to point at the screen and say, hey, get me a little bit closer view of that. And but as far as any specific thing, we have set up autonomous flights before, but I myself, I like to fly, and I usually fly everything myself, but we do use autonomous stuff here and there too also.
Very cool, very cool. Going into the next section of our webinar, results. We went over some of the solutions, and now we kind of want to go see some of the results. So I'm going to pass this one on over to Clint and his slides. But going into the results, what benefits and results can we expect with drones in oil and gas?
So what I'm going to touch on before I go to the thermal benefits is going back to how often you inspect, one of the things that's great is the federal government, they require certain areas to be inspected twice a year, semi-annually. And it's usually pipelines that are going through cities, underneath cities. They want to make sure the integrity of those are safe. And before, again, they would have to be walked. It's not something you could ride a side-by-side or four-wheeler through, because we're going through neighborhoods and we're going through schools and certain areas where you have to get out and walk. And having to do those twice a year and then send reports federally, it took a large chunk of time, and it took several people. And so one benefit that you're going to run into is now these semi-annual reports, they can be done in a couple days versus what takes weeks before. Then you come into the thermal side of this. We have an example here of a flare stack being inspected. That was just checking the thermal side of it, making sure that there's no areas that are popping out the side, causing any hot or cold zones based on the gas venting. Then there's also another one of us zooming to those. Here is an example of frac, collecting frac sand. That's just a very clean way of showing you that we can see tank levels. An easy way to do that is if you go to the tank itself and check the temperature of what's inside the tank, you can change the parameters of the temperature that you're wanting to see, and it makes it pop beautifully. And so a lot of times what they used to do is there's sensors on the computer to see how high the tank levels are, but they don't always work. So in order to verify them, what they used to do is something called a color cut process. And what that is you're using a liquid on basically a tape measure, and you're dropping it all the way into the tank, and you're seeing where it changes colors. And that's how you know the level. Whereas now you can take a drone and see exactly where the level is and verify it that way. It's a whole lot quicker and easier. And then the image on the right was a quick thermal flight we did over a facility, and you can see a couple cold spots there. That's where a regulator was venting harder than it was supposed to, causing the cold spot. Another benefit of thermal that you can do is these pipelines will form something called ice plugs or hydrates, where they're venting around a corner or they're just venting harder than they're supposed to be, and it'll freeze up and form an ice plug. Well, not only are these dangerous, it stops the flow of the gas. And the way to find it before was you have to go to everywhere that you have a header or a riser coming out of the ground, and you need to check your pressure in that area. But if you have above ground pipe that you can check with the thermal, you can see exactly where the gas stops and exactly where the ice plug is. It saves time, and it's a whole lot safer because that pressure buildup, you're able to find exactly where it is and get the pressure released. So the thermal benefits are incredible for oil and gas industry. And then this is an example of 3D model of a facility that we put together using the M300 and the P1 camera. The presentation behind this is great because what executives are having to do, they're having to go to their board members and they're having to show their compressor stations or showing what they've built and what they put together. And they're having to use what's called PNIDs, and maybe just where they're showing kind of where the gas comes in and where it leaves, and then they're just showing basic pictures of the site. If you give them a 3D model to take and present, and they can check everything that they need to and show them everything that they have on the site and on the location and walk them through the entire process, they love that, and it helps them tremendously.
Yeah, that leads to a good point. When you mentioned 3D model, I'd like to ask the audience today if they've ever generated a 3D model before. I'll be launching a poll. All right, I'll be closing up shortly. It looks like about 73% of people voted. Okay, I'll share those results. So it looks like 76% of people voted. It's kind of like a coin toss right here. 58% of people have said yes, and 42% have said no. I was actually expecting a lot more no's, so kind of surprises me a little bit, but we can let Clint kind of continue talking about a little 3D models. Let me hide this results.
Yeah, so 3D models are something that's incredible for use. One example is, again, to show how it is easy to understand. Somebody who doesn't fully know what they're looking at with a refinery or with the PSM facility or process safety management facility, they can pull this up and they can be walked through it very simply without having to actually take them to the location and walk through it. It's something that is fast. They can show them why they spent the money, where they spent the money, and what it's for. So it's easy for investors to understand what they did and why they did it. What I really like too is on an international level, you know, there's a lot of investors from overseas now getting in the oil and gas industry, and you don't have to, there's a lot of times a language barrier you run into that is taken away with a 3D model. They can see exactly what you're seeing and they can figure it out. When you talk about project approval, a lot of times you want to upgrade a location or a site, you want to add a separator, or you want to do something to make it run more efficiently and cause less problems for the operators, and you can walk them through that process. A lot of times adding a separator, which is just separating the oil, gas, and the salt water, it doesn't make sense until you lay it out for them and show it to them. And a 3D model makes that a whole lot more doable than trying to walk them through what's going on. Another thing that I've loved is when you have experience with that location and you're trying to get somebody else to go out and fix a valve or fix a situation out there, you can show them exactly what you're talking about. You can zoom in and say, this valve right here, I need you to go out and change it. Whereas before they were having to explain it. And then also the benefit of being able to zoom in and see what type of valve. There's several different valves that do the exact same function, but the size will change or the type will change based on what they had at the time or the plan that they had for that facility. So now you can pull up a 3D model, come into it and say, okay, that's the type of valve on that location. And you can come with what you need without having to make a separate trip. So it saves you a lot of time and energy in that regard as well.
Thank you for that, Clint. This kind of goes into my next slide. I'd like to kind of talk about having the right tools. And today we've seen a lot of solutions and a lot of great results. But without that, it wouldn't be possible without the right tools. So I kind of want to introduce DJI Enterprise's current lineup right now. We have our Maverick 3 Enterprise series, which is our entry-level enterprise drone. We have 3 variants of that. We have a Maverick 3E, which stands for the enterprise, for users that are looking for a good, powerful mechanical shutter, visual camera. And then we have our Maverick 3 Thermal for customers that need a small size thermal drone. And then we have our Maverick 3 multispectral for people looking to do vegetation and any multispectral data with DJI Terra. And then that kind of goes into our middle-sized drone, our Matrice 30 series M30, maybe for customers that are looking just for that quad sensor that the H20ET provides, a thermal laser rangefinder, wide and zoom camera. And then we also have our M30T dock, which is our drone in the box solution currently right now, still in beta, coming out in the near future. And then we have our Matrice 300 RTK, which I had the opportunity to introduce a little bit about earlier, with interchangeable payloads such as a L1, which is a LiDAR, P1 photogrammetry, our H20, H20T, H20N, and even third-party payloads such as spotlight speakers, the U10, the methane sensor. So that's all possible because of the M300, and then some of our software side. I think we spoke a little bit about DJI Terra for modeling, DJI Flight Hub, drone operation management platform, and then DJI Thermal Analysis for any of those thermal photos for any radiometric data or temperature readings you would need. So that's kind of the tools the tools for the job, the ecosystem of it wouldn't be possible without some of these tools that Clint and John were speaking about today. But thank you, Clint, for sharing some of your results. I'm gonna slide over to John to kind of go over his results at PAMX.
So that's already been well covered. The inspections of the fin fans and the flares, huge win for this program. Next slide. So here is just the different types of how to show your leadership, your value add. Of course, any first goal of any program is the safety, but also it's good to have that secondary goal of course, money and the savings. So different ways we've highlighted that throughout the years. The first 2 years of the program, the program holder was a gentleman by the name of Tim Hill. He had extensive operations background and then moved into the security field. And so he was able to put actually dollar amounts to the different things that we had did in 17 and 18. And then we were able to put the note there on the bottom that these items here were only 20 missions out of 160. And 20 missions end up saving 1.4 million those first 2 years. And then the next 2 years where I became the program holder, I put just the basic numbers to what we did. 1,800 tank inspections, 260 different various inspections, and that's how we prevented the program then. And then it got to a point at late 2020, I think maybe early 21, the HSSE manager asked me to put a dollar amount on the savings for the first 4 years of the program. And so using very low estimated figures for the different inspections we did there in 1920, we were able to come up to the site had saved 7.4 million over 4 years. But then very also note to put in there that also within the first 2 years, we saved, I believe it was like I think it was over 1,200 times where we saved a person staying on the ground and not having to go at height to do an inspection to try to find a block valve and a pipe rack, various different stuff like that. We were able to use the drone and throwing that safety aspect back on it, where someone stayed on the ground, we put the drone in the air, and the drone took the risk of being at height and not a person. Next slide, I think is wrapping it up.
Yep, thank you for that, John. That leads us to our next webinar section. We're coming toward the end. We have a survey for everyone. You can either type that in or you can scan the QR code. Go ahead and pull up your camera and scan that. Should bring up a survey. And we'll give you the opportunity to either fill that out right now, or if you want to at the end, but we'll take like a few minutes for you to fill out that survey. That'd be really helpful for us. Thank you. All right, if you haven't finished the survey, please feel free to have it pulled up and at the end of the survey and just continue filling it out either throughout or at the end. We'll move on to our Q&A section. I do have some questions that we've already had previously submitted that we'll try our best to answer, and at the end we'll be able to also answer some questions that you've asked during this webinar. So Q&A. Some questions I want to ask, feel free to jump in anytime, Clint and John, but I want to ask, in the oil and gas industry, how do you manage a UAS program while balancing other day-to-day tasks? I know examples, sometimes this might not be your full-time job. You know, someone might be in charge of another section or department or working on something all different together. How are you able to complete your regular day-to-day and also manage your UAS program at the same time? How are you balancing that out?
What's great about it is you're not doing anything that you weren't doing before. You're just using tools to do something more efficiently, quickly, and more safe. And so the day-to-day doesn't change aside from updating and maintenance and logs. The amount of time you save using the drone, you have plenty of time to do those things. So pipeline workers that were already running pipelines, or environmental health and safety workers who are already doing leak detections, they are doing it still just with a drone now and saving tons of time and money in the process. If they add pilots to do that full time and report to those people, it even saves more time. But the regular day-to-day tasks that you do, honestly, you're doing the same ones, just quicker and safer. And so it opens you up for more time, in my opinion. It's not an extra burden. It's freeing you up to handle what you need to handle.
So I'm fortunate where I have a split role as managing the drone program, which is 80% of my role, and then the other 20% is supporting the security department as a whole. So I do have some security specific duties, as in supporting turnarounds when planning for turnaround, you know, where we're going to bring people in, where they're going to park and stuff like that. But of course, you know, turnarounds is a 2 to 4 events per year. So it's not really nothing that's going to take a bunch of time. The other one is monitoring the field execution of the contract security company. So I'm able to dedicated, you know, time to the drone specifically, and then to the security part of my role. So there's times when they overlap, but just like Clint mentioned, it's not nothing that you weren't doing before. So it's not really all that hard to balance.
Okay, yeah, that's good answers. Okay, so another one is we've gotten, what key information do you share with management to keep them involved and on board with your program?
So we have a dashboard that we keep, as far as how many missions we have flown per month, and then that equals to how many flights and specifically what the mission's for. And then the site leadership team gets that dashboard every month, and then we do a quarterly total, and then we do an annual total. So that's shared, constantly with the site leadership team to keep them involved and knowing, the value of the program, and by additional of newer tools as newer technology comes out, what those tools are doing for the site, and also the safety aspects, and the secondary has already been mentioned, the money saving that goes along with that.
For me, a lot of times just sharing the success stories. You would think that they wouldn't want to hear about leaks, but the fact that you're finding them and fixing them, a lot of these people are very environmentally conscious, and so they're not wanting to hurt the environment. And then also, gas that is going into the atmosphere is not going down the pipeline, and at the end of the day, not making them money. And so when you show them the leaks that you find, say found two leaks this week, and you're constantly keeping them involved in that process and how you fixed it, they're seeing the value every week. So just sharing, the regular day-to-day where you don't pop anything is good, but showing the success stories and keeping it fresh on their mind, it makes it so that they see the value.
Yeah, another one we got today was what are some hurdles your drone program has overcome that you can speak on to help with others? I know John spoke a little bit about Hurricane Harvey and different issues that Clint also had, but yeah, how's that made your program stronger or better? And I know other people are listening today and they want to hear how they can overcome some of those hurdles.
Yeah, so I think another question that might have already been asked that will probably, shoot them down here all at the same time. But the first big obstacle, of course, we had to overcome was, is the drone intrinsically safe? And the answer is no, it's not. So we had to right off the bat engage our health and safety reps and also our electrical engineering department and operations, and come up with a plan on how we're going to fly the drones, around the operating units and the classified areas. So basically what we have written into our SOPs, on the recommendation of the electrical engineering department, is our largest classification area is 48 feet. So just to round it up, we have in our SOPs that we will not fly any closer than 50 feet to any piece of equipment, which over the last couple of years, with the development of the different cameras, specifically the H20, which has a rangefinder on it now, before where we were eyeballing 50 feet, we have a rangefinder that ensures we are staying 50 plus feet away from any piece of equipment. That was our first big hurdle to overcome, which engaging the right people, we were able to overcome and write the right SOPs into the program, which has made us very successful.
Yeah, we ran into that same problem. And when they're talking about intrinsically safe, a lot of times they will say you need to remain 100 feet from it or 50 feet from it, as John's saying. And with the payloads that we have, 50 to 100 to 150 feet are not a problem. And so getting them to see that we could still do what we needed to do from 150 feet away, that helped tremendously. But then also, as I was stating before, you need to make sure that you go to every department and explain to them what a drone can do. What I was running into is I would see somebody up on top of an area where they were trying to inspect something, or they were trying to count the bolts that they needed to replace, or things that a drone can do that they didn't realize it could. And so when you go to each department and you say, what is it? Then you brainstorm with them, like, how can I help you? Let me show you what a drone can do. And you start narrowing down how it can be best effective. That's how everybody gets on board with it, because they don't know what you know as drone pilots. They don't know what you can do and what you can't do. They don't know how it can benefit them. So taking it to them is going to help you a lot.
Very good observations and advice. And we'll go dig into some more Q&As we've gotten also. A question we got was an event of an accident. How do you transmit the images from the scene of the incident to the proper personnel as soon as possible? I think we talked a little bit about this earlier. When they talk about an event of an accident, I don't want to confuse anyone. It's not an event of like a drone accident, but I think they were referring to an event of an accident like on a FLIR stack or some type of pipeline. How would you transmit the images to the proper personnel as soon as possible?
So basically for us, anytime we have an incident on site, a large incident, we're going to stand up an EOC. As part of that EOC, there's an air ops section. And so we're able to live stream video straight from the scene right into the EOC, right directly also to the incident commander, where they're getting live up-to-date images At the beginning, like I mentioned, it'd be running back and forth from the scene to the EOC, with the SD card, and the people behind you, is that my video, my video? Now with the live stream, which there's plenty of different third-party softwares, and also DJI now with Flight Hub 2, you can live stream, directly from the software that you're flying with, and that is the most effective way to get your images back to the people that need to know.
Yeah, that's great. You mentioned Flight Hub 2. I think I touched a little bit about it in some previous slides, but introduction to Flight Hub 2 for people that don't really never used it or maybe used Flight Hub 1, reminder. But yeah, it's a cloud-based drone operation management platform. You're able to live stream all our DJI Enterprise drones and give you live and annotations even during the mission. You can review operation results in the cloud. You can open any captured photo, video, or panorama, and it can be displayed on like a 2.5 base map, along with corresponding coordinated information. So that's a great tool that we have for our enterprise drones. Yeah, the next question I want to ask, Clint, what are some, I think you spoke a little bit about it, some mapping and photogrammetry and LiDAR, but yeah, what are some benefits of photogrammetry in comparison with LiDAR and vice versa?
So just as we were talking before, you always want to do your flight planning case by case, and photogrammetry versus LiDAR is no different. There's going to be certain situations where photogrammetry is better, and there's certain situations where LiDAR is better. I think a good example for the oil and gas side is LiDAR is very quick and efficient at getting you a point cloud. And so if they want to clear out a certain area, or they want to look at an area they're going to drill, or you're in a tough terrain type area, LiDAR is very efficient, getting you a good accurate point cloud. If they want to see what power lines are in the area that they're dealing with, LiDAR is great because it can pick up things as small as power lines. And so it can help with planning a lot of times is what LiDAR is used for. It's great for planning a location that hasn't been cleared or that you're in the process. Photogrammetry is easier to get deliverables. It's made a lot for, in my opinion, what's already established. You can get your 2D orthomosaics out of photogrammetry, and you can get these 3D models that have been stitched together with your photogrammetry of sites that you've already done. So I feel like photogrammetry is ease of use on deliverables and getting the clear image that you want. And that's where that use is. And if you want to plan a new location or a new site and you have to deal with terrain, trees, power lines, all of those things, that's where LiDAR is more effective in my opinion.
Awesome. Yeah. I kind of want to hit on some of these questions that people are asking during the live webinar. Now we can come back to some of these questions, but this one was targeted for you, Clint. He wanted to ask, Nick wanted to ask, what are the saltwater lines used for? I know in some of your slides you showed some of the lines.
Yeah, that's a great question. So when they drill wells, what they get out of the ground is they get the natural gas, oil, and salt water comes with it. So the whole process of oil and gas facilities are trying to separate that. So they have clean natural gas that they are selling to their customers, clean oil that they're selling, and then there's salt water that is basically the waste that comes out of it. So what they use the saltwater for is they take the saltwater lines usually lead to saltwater disposal areas where they get rid of them, or it leads to tanks where trucks come and load up and get rid of them. So it's just efficiently getting rid of the salt water, so it's not just going back into to damaging areas. So that's not something, of course, that they sell. That's just basically the waste that comes off of the natural gas and the oil, and it is their responsibility to dispose of it properly.
Oh, very awesome. Very cool. Okay. Yeah, another question. This one's for you, John. I think you spoke about it a little bit. Mark asks, how do you deal with the requirements for the intrusical safe requirements? I think you were speaking about that the M300 having that requirement, and you said it wasn't. How do you deal with that with your oil and gas program or company asking you these questions and maybe even potentially requiring it?
Right. Yeah. So any sort of manufacturing facility is going to have classified areas. It's just learning through your electrical engineering department, what is the size of those classified areas, and you just stay away from those areas. We do have a process that if we just for some reason don't have the zoom capability or whatever type of image that is trying to be getting in a process area, we do go through the hot work permit, where the pilots we're flying. We all have 4 gas meters when we fly. Operations will go in and they'll sniff the areas, with their various sensors, and just like welding in an area or whatnot. They'll do the live monitoring, gas monitoring, and we'll get in that classified area and get the image. But as Clint has already mentioned, with the cameras that are out today, all the enterprise solutions, there's really no reason why you would have to fly within a classified area to get any image that you're looking for. The H20Z has basically changed the zoom game, where basically I call it, when you get into the digital zoom, you're basically still getting an HD quality, high quality zoomed in picture. It's just amazing what these cameras can do.
Thank you for that. I have a question, I guess, for both of you guys. I see Safik asked this question, and I also see in the names today some names that are familiar from different drone service providers that I've worked with. So they asked, what advice would you have for service providers serving larger oil and gas companies? I know today you guys spoke about from your perspective of actually working for the oil and gas, but what about people that use drones for a living and want to get into the oil and gas inspection and have that added to their company's line of tools that they want to provide?
I think the big thing to do is to show them how you can take the nuisances away from them. Like I said, the federal regulations that they have to inspect, the flare stacks, as we talked about, all these things that they have to do per federal requirements, showing them that you can take it from them and do it quicker and more efficient. I think it opens the door for you in a very large way. It makes it a no-brainer for them because they don't want to do it. They have other things they need to do. They have more time that they need to spend elsewhere. And it's honestly, as I said, a nuisance. And so showing them that it's something that you could effectively take away and get them quick, accurate data, it opens a door for you in a good way.
Yeah, for me, I would say and give the advice: be prepared to deal with the, especially in a larger company, the company's aviation department. So make sure your SOPs are robust and cover your emergency response plans and have procedures for emergencies. Have details on how you conduct your maintenance on your drones and how how you prove to the FAA that your aircraft was airworthy. Just all those basic guidelines outlined by the FAA to make your SOPs and make them robust. And also make sure you have your flight records available. Your Part 107, they're going to want to see all that, and you're going to have to go through their review before you get to mine or Clint's level. Luckily for me now with Pemex, I am the aircraft department. So you provide that. But for other major oil and gas companies, you're going to have to deal with the aviation department before you come down to the site level.
Yeah, thank you for that. I wanted to pull up the survey link and QR code one last time before. I think that we're wrapping up on time right now. It's 9:30 a.m. Pacific time. That concludes about an hour and a half webinar for oil and gas and UAS solutions. I want to thank Clint and John for being here today. It's been an amazing experience, and there will be a recorded video of what just had occurred, and be sent out to everyone. I want to thank everyone for attending also this early morning or afternoon. But yeah, thank you so much, Clint and John, for attending this webinar and speaking, and I'm sure you've helped out a lot of people viewing in today, either starting a program or already have a program or just trying to find out more information or even being in a completely different industry. I guarantee you that they've learned something valuable today and take it onto them in their UAS future. So again, I'd like to say thank you so much, gentlemen.
Thank you.
Hopefully our emails are out there someplace within the webinar. If you have any questions that we weren't able to cover, please reach out by email. I'll be happy to help in any way I can.
Absolutely. Yeah, I second that.
Well, goodbye, everyone. Thank you.
You.